Okay. Number 15, the limit x going to 0 of sine 3x sine 2x. Now, there are two ways to do this. 15, the question 15 said, use a calculator to numerically verify that limit. So that's one way you can do. You can plug in values close to 0, say 0.1, 0.01, 0.001, and so on. And also, you should try the negative values and compute this, and you're going to see that your calculator gives you some value that's very close to 1.5. So it gets closer and closer to 1.5. Okay? So that's one way to do it. However, another way to do this is, it says in 16, question 16, reduce CDE of question 15 using analytical methods. So let me try to use analytical methods for this. Right? Okay. So the way you do analytical method is, first you have to remember the limit of x going to sine x over x going to 0 of sine x over x is equal to 1. This we learned, right? Now, with this, you have to know that if you have limit x going to 0 of sine ax over x, suppose you have to solve this. Well, the way you do this is by substitution. You can say t is equal to ax, so that x is equal to what? If t is ax, can you solve this for x? Yeah, so x is t over a if you solve for x. And therefore, you can rewrite this as sine of t, ax is replaced by t, and x is replaced by t over a, and then how about x going to 0? If x goes to 0, if x becomes very small, what happens to t? If you plug in 0, what is t? T is 0, right? So t goes to 0. So you end up with this division by a can be thought as multiplication by a. So you end up with sine t over t, and what's that? This is just 1, so you end up with a. So using this, you can just use this and say, it can do this, like, take this limit x going to 0. You can divide top and bottom by x. And use the formula that we just did. We just used, right? If you divide top and bottom by x, then both top and bottom look like this type, right? Therefore, you end up with 3 on top and 2 on the bottom, which gives you the limit below 2. That's it. Just the application of this. So that's how you do 15D. Now for 15E, limit, what was it? The limit x going to 1 of x minus 1 over absolute value of x minus 1. Now, this is a totally different type of question. This has to do with being able to write down absolute value of x minus 1 as a piecewise function. So, in order to evaluate this absolute value of x minus 1, the question is whether x is bigger than 1 or less than 1, right? If x is bigger than 1, what would you do? If you wanted to evaluate this and you plugged in x bigger than 1, what would you do? Say you plug in 3. 3 minus 1 is 2. It's a positive number, so what would you do? Huh? You don't do anything. That's what absolute values do, right? If it's already positive, do you do anything to it? Nothing, okay? So you just give back what was plugged in, right? So if x is bigger than 1, or even if it's equal to 0, it doesn't do anything. See, this is exactly the same as before.
Question.
Yes?
This is F, not E.
Oh, this is F. Okay. Okay. Now let's look at the case when x is less than 1. Now, if x is less than 1, it would do something, wouldn't it? Right? Absolute value of x minus 1 wouldn't be just x minus 1. If you write down x minus 1, it's like not doing anything. So I have to put something different. What should we write? Anybody?
0.
No, it doesn't give you 0.
No.
So for example, if you plug in -1, I want it to give you 2. If I plug in -2, this should be whatever you put here. Hmm? That's right. You put a negative in front. Now, don't be fooled by this minus. As a whole, is this positive or negative? It's a positive number. Why? Because x is less than 1. If x is less than 1, x minus 1 is negative, and putting a minus in front of a negative number gives you what? It's a positive number. So don't ever be fooled by this minus sign, thinking that this is a negative value, and it's like, oh, what happened? I thought absolute values always gave you positive. Well, it does always give you positive. It just looks strange. Okay? Don't judge by its appearance. It's really a negative number. Yes?
What tells you to use a piecewise function to determine? Is it always absolute value that's...
Yeah, absolute values, you either want to use a piecewise function or you can graph it. That would be another option. You can figure it out by doing both cases. All right, so using this, we now can think about limit of x going to 1 plus of x minus 1 over x minus 1, and also limit, limit x going to 1 minus x minus 1 over absolute value of x minus 1. Okay. I'm choosing these two as different cases because whether it's bigger than 1 or less than 1, depending on whether it's bigger than 1 or less than 1, it's going to use different definitions for this absolute value, right? Okay, so for this one, what is it? What does this bottom thing evaluate to? Same thing, right? The bottom is positive, so it doesn't do anything. So limit x going to 1. And what is anything divided by itself? 1. So you're really doing limit x going to 1 of 1, which is just 1. Okay, how about this one? What does the bottom evaluate to? This bottom absolute value of x minus 1 can be switched to negative x minus 1. So that's what we figured out, right? So what is that? Limit x going to 1 minus 1 over negative, no. Just, if you divide top and bottom, you just get negative 1. So the answer is negative. Okay, we're still not done. What did we just do? We took a right limit and got 1. We took a left limit and got negative 1. What does that mean?
Doesn't exist.
The limit does not exist. So the answer, the proper answer for this is it diverges or it does not exist.